Hello everyone, we're going to go ahead and do section 6.9, which is solving quadratic equations. So as an overview, the main theme of our study of linear equations and inequalities is that they can help us solve a wide variety of problems in our world. But there are not many other types of equations, and not every problem can be solved with a linear equation. But there are many different types, and not all can be solved with linear equations. So for example, the motion of an object through the air, like bungee jumpers, can be described by equation with the highest power being 2. So something like x squared instead of just an x. And we call these quadratic equations, and we'll study them in this section. So quadratic equations and definitions. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are all real numbers and a can't be equal to 0. We just say that a can't be equal to 0 because if it were 0, then you'd have 0 times x squared, and that would be 0, getting rid of your x squared in general, which would make it no longer a quadratic equation. And the form above that we see here, this is called standard form. Standard form is ax squared plus bx plus c equals 0. A binomial is an algebraic expression with two terms in which any variable has a unique whole number exponent. So for example, something like x minus 5, 2x plus 3, negative 6x squared plus 4x. So it only has two terms. But a trinomial is an algebraic expression with three terms in which any variable has a unique whole number exponent. So for example, something like x squared minus 5x minus 24, or something like 6x squared minus 31x plus 40. So this leads us into factoring. We can use factoring to rewrite a more complicated problem into the product of simpler ones. So we use factoring to simplify trinomials, or equations of the form ax squared plus bx plus c. So factoring will allow us to solve quadratic equations. And factoring is the reverse of the distributive property. So your distributive property would be a times b plus c. We distribute the a to get a times b plus a times c. Factoring is the opposite of that. So that would be going from a times b plus a times c to back to a times b plus c. So the distributive property allows us to distribute the multiplication operation to each term in parentheses. Factoring is the distributive property in reverse, but also we're working with expressions now instead of just numbers. So we use the FOIL method for that. So the FOIL method is the distributive property for expressions. Within our FOIL method, we have a plus b times c plus d. So we're multiplying our two terms together. And so FOIL stands for first, outer, inner, last. So first, you'll multiply the first numbers or terms in your two chunks there. So you'll have your first would be your a times your c. They're the first of the two. Then you have your outer, so your outer terms, your a times d, so it's the 2 on the end. And then you have your inner terms, so your 2 in the middle, so b and c, and your last terms would be the second terms in each chunk. So that would be your b times d in that case. So when you multiply that all out, it turns into a times c, which was the first, a times d, which was the outer, b times c, which was the inner, plus b times d, which is the last. So that's the FOIL method on how to multiply out your two binomials there using the distributive property. So we're going to multiply our following binomials using the FOIL method. So for a, we have x plus 7 times x plus 9. We use the FOIL method to multiply out each term together. So we multiply the first terms, then the outer terms, then the inner terms, and then the last terms. So we have x plus 7 times x plus 9. Multiplying our our first terms, we have x times x, which gives us x squared. Then we add our next one, so we do the outer. So this would be x times 9. Those are the two on the outsides. So x times 9 would be 9x. Then we do the inner terms, 7 times x. And then last, our last terms, 7 times 9. So then we get x squared plus 9x plus 7x plus 63. So now that we have that, we just want to make sure to simplify. So we'll combine our like terms to simplify our answer. Our like terms are the ones in the middle. X squared and 63 don't have like terms, but 9x and 7x are like terms. So we'll add those together so that we get x squared plus 16x plus 63. Then for part B, we have 4x minus 8 times 2x plus 5. So we'll multiply those together. We use the FOIL method, just like before, to multiply each term. So starting with our first terms, we have 4x and 2x, so we multiply those together. 4x times 2x gives us 8x squared. Then we do the outer terms, so 4x times 5, so the ones on the outside. 4x times 5 would be 20x. Then we do the inner terms. Negative 8 times 2x gives us negative 16x. And finally, the last terms, negative 8 times 5, which is negative 40. So we write those out. Now, when we have minuses, we typically treat that as a negative, and instead of adding a negative, we usually just write subtraction. But you can always write adding a negative or plus a negative number if you'd like. So we have 8x squared plus 20x minus 16x minus 40. So just like before, we're going to combine our like terms to simplify our answer. Our like terms are 20x and negative 16x. So we'll add those together, which will give us our final answer of 8x squared plus 4x minus 40. And there we go. So now more on factoring. The factoring that we will often use is for factoring trinomials, expressions of the form ax squared plus bx plus c, where a equals 1. So typically, or a lot of the times, we'll see that a, or that number in front of x squared, is 1. And a lot of common and easier factoring techniques come with that. So the first one we have is the generic factoring technique. This is the one that we'll use probably most often. The generic factoring technique works for all different types of factoring for trinomials as long as that first term a is 1, meaning that you just have x squared and then the rest of your terms. So for the generic factoring technique, what you're looking for is that you're looking for your trinomial to look like x squared plus, and then it will have a number in the middle, your b value. But for us, we're going to treat that as a plus b, so there's some number in the middle, plus the number at the end, a times b. So you're looking for two numbers, a and b, that multiply to the value at the end and add to the number in the middle. So, and when you factor that, it turns into x plus a times x plus b. So for example, if we have x squared plus 5x plus 6, we want two numbers that multiply to 6 that also add to 5. So we would go through all the factors that we know of 6. We know 6 and 1, but 6 plus 1 is 7. It's not 5. You can have negative values as well, so you could do negative 6 or negative 1. Negative 6 and negative 1 would make negative 7, so we're still not at 5. And it is a positive 6, meaning that those two numbers have to both be positive or both be negative, since it was a positive 6. So those are the only options there for 6 and 1. And then maybe by this point we've thought of, oh, hey, 2 and 3 multiplied together also equals 6, and 2 plus 3 is 5. So in that case, you found the two numbers a and b, where 2 plus 3 equals 5 and 2 times 3 equals 6. And so the factoring format would be x plus 2 times x plus 3. So that's an example of that technique being used. So you want to look for two numbers that multiply to the last number and also add to the middle number. Then when you factor it, it just turns into x plus a times x plus b. If one of those numbers happens to be negative, you would just make it subtraction instead of addition. Then we also have the difference of squares and the perfect square. So the difference of squares is a problem of the format x squared minus a squared. So a squared is just some number at this point. So x squared minus a squared factors into x plus a times x minus a. So for example, if you have x squared minus 9, well, 9 is the same as 3 squared. So this is also the same thing as saying x minus 3 squared. 3 being the value of a, which means that when you factor, it turns into x plus 3 times x minus 3. So by identifying the value of a, you can pretty much factor it immediately just by knowing that value of a and knowing the format. Then we lastly have the perfect square. So the perfect square is x squared plus 2 times a times x plus a squared, and that equals x plus a squared. Then we also have x squared minus 2ax, so 2 times a times x, plus a squared is x minus a squared. So examples of this would be something like x squared plus 8x plus 16. So some number that squares itself to be 16 and also times 2 equals 8. So you can take the square root of that number at the end. So the square root of 16 would be 4, and 4 times 2 is 8. So the perfect square would be x plus 4 squared. Then we have x squared minus 10x plus 25. So the square root of 25 is 5. 2 times 5 is 10. So our answer there would be x minus 5 squared. So you can use these different techniques when you are factoring trinomials. The generic factoring technique is most definitely the most important one that you'll want to know. But the difference of squares and perfect squares are also very good to know. The generic factoring technique will help you with any of the other terms or any of the other forms, though. So that one's the most important one to know. All right. So the ones that we just saw, those were all the formats that we could use to factor trinomials. If a, the coefficient in front of x squared, were 1, but that doesn't always equal 1. So when a does not equal 1 in standard form, which is ax squared plus bx plus c, it can make factoring quite a bit harder. So here are the steps that you want to take if you need to factor a trinomial like that. So for example, this would be something like 2x squared plus 7x plus 3. There's a coefficient in front of x squared, meaning that a does not equal 1, and you'll most likely have to use a different and probably harder factoring technique. Now, before we go into the technique, it is always a good idea to try to just factor that number out of your entire term or your entire trinomial. But in this case, with 2x squared plus 7x plus 3, 7 and 3 are not easily divisible by 2, so that's not a good idea. If they were easily divisible by 2, it'd probably be best to just factor that number out and then try to factor what numbers or what trinomial was left over. That would usually be easier in that case. But all right, so we can't do that, so let's go ahead and try to figure out how we would factor. So step 1 that you would do is you would multiply a and c together. So a is the coefficient in front of x squared, and c is the number at the end. Then you find two factors that multiply to be equal to a times c and add to equal b, the number in the middle. This is very similar to our generic factoring technique. So with 2x squared plus 7x plus 3, we multiply 2 and 3 together. So 2 times 3 is 6. So we'll want to find two numbers that multiply to 6 and they add to equal b, the number in the middle. The number in the middle is 7, and we just actually talked about this. So two numbers that multiply to 6 that add to 7 would be 6 and 1. 6 times 1 is 6, and 6 plus 1 is 7. So what you'll do is that you'll separate b by the sum of those two factors. So step 2 is once you have your two factors, you replace b with the sum of the two factors that you just found. So for our case, this would be 1 and 6. So instead of writing 7x, we're going to write plus 1x plus 6x. Once you have the two factors, you're then going to replace, step 2. Then you'll want to group your terms, there you go, so that you can factor out the greatest common factor from each group. So once you have your 4 terms now instead of having 3 terms. You'll have 4 terms and you'll group them together. Grouping just means to put parentheses around them. So you'll put parentheses around the first 2 and the last 2. So you'll get 2x squared plus 1x and 6x plus 3. So once you've grouped them together, you factor out their greatest common factor, which is the biggest thing you can take out of both. So for our first group, which is 2x squared plus 1x, you can take out an x. If you remove an x and you factor it out, so you put x in the front, you get x times 2x plus 1. Then for our second group, which is 6x plus 3, the biggest thing we can factor out is a 3. So we can factor out 3, which would give us 3 times 2x plus 1. Now, the important part, which is step 4 here, is that we should realize that they have a common factor, which we can now factor out and solve. So the common factor is basically what's left over when you factored out your greatest common factors from each of your groups. So once you factored out your greatest common factors, which were x and 3, in both groups we were left with 2x plus 1 for both. So what happens then basically is that you take out 2x plus 1, that becomes its own factor, and then you group together the 2 coefficients. So your 2 coefficients were x and plus 3, so that becomes x plus 3. So you factor out your 2x plus 1, or your common factor, and whatever was left over in front as the coefficients or your greatest common factors, that becomes the other factor. All right, that's the method that you can use when factoring a trinomial when a does not equal 1. So we can use some helpful principles in solving quadratic equations using factorings and steps to make problem solving easier. So we can use the principle of zero products. This tells us if a times b equals 0, then a and or b equals 0. So that means that a has to equal 0, or b has to equal 0, or they both have to equal 0. If a equals 0 and or b equals 0, then it's guaranteed that a times b will equal 0. So when we're factoring, and a lot of the times when we factor trinomials, we're trying to solve for x. So when we want to solve a quadratic equation by factoring, we would factor our trinomial and then set them each equal to 0 to solve for x. So for example, if we have x squared minus x minus 6 equals 0, we want to factor the trinomial x squared minus x minus 6. So we have negative 6 is the number that we want to try to get 2 numbers that multiply equal negative 6 that add to equal negative 1. So that negative x is there in the middle, but remember that means minus 1 or negative 1x. So we need 2 numbers that multiply to negative 6 that add to negative 1. And so 2 and 3 are definitely our best options there. Then just figuring out which is negative and which is positive. So since the middle number is negative, that means that the bigger number will be the negative number and the smaller number will be the positive number. If the middle number were positive, that would mean that the bigger number were positive and the smaller number were negative. So that means it's going to be negative 3 and plus 2. So we get x minus 3 times x plus 2 equals 0. So we factor our term there, and then we set them each equal to 0. So following our steps, our step 1 is to write the quadratic equation in standard form. So you just want to make sure that you've got your x squared first, then your x term, and then your non-x term at the end. And you want to rearrange it as well so that 0 is on the right side. So you want your trinomial equal to 0. You don't want your trinomial equal to another number. If it's not equal to 0, then you just make it equal to 0. Just subtract anything over on the right-hand side over to the left. Then step 2 is you factor the left-hand side, so you factor your trinomial. Step 3 is to set both factors equal to 0. So you take each of your binomials and set it equal to 0. So we had x minus 3 and x plus 2. So we take x minus 3 and set it equal to 0. And we take x plus 2 and set it equal to 0. So we have x minus 3 equal to 0. We add 3 to both sides, solve for x to get x equals 3. And then we have x plus 2 equals 0. We subtract 2 from both sides to get that x equals -2. And then step 4, we solved each equation there. So you can solve for x by just taking each of your binomials and setting them equal to 0. Now lastly here we have the quadratic formula. So we learned a lot of different ways how to factor and things like that, and those definitely can get you to the answer a lot easier, very simpler, but the quadratic formula works every single time. So the quadratic formula will always work every time you try to use it. It could definitely be in your back pocket for whenever you want. And if everything else is too difficult, you can always use the quadratic formula. It will work every single time, but it is longer, it is cumbersome, it's got square roots and fractions, so it's kind of a toss-up on what is considered easier. Factoring is generally considered easier when you can factor, but the quadratic formula is used for when you can't factor. So we can use the quadratic formula to solve for the solutions of any quadratic equation, which is ax squared plus bx plus c equals 0. So the quadratic formula solves for x in this case. So the formula is x is equal to -b plus or minus the square root of b squared minus 4ac all divided by 2a. There's a little rhyme to this. We say the negative boy couldn't decide whether or not to go to this radical party or be square and miss out on meeting 4 awesome chicks, and the party was all over at 2 a.m. So it was a little rhyme to try to remember what the formula looks like. There's lots of different rhymes out there if you would like to find a different one that you like more or anything along those lines, but that's a quadratic formula. So as a warning, when you're using the quadratic formula, you will be working with square roots and fractions. So you need to keep an eye out for when things can be simplified and when they can't be simplified. So as an example, we're going to solve the following quadratic equations by factoring or using the quadratic formula. So A, we have x squared minus 12x plus 20 equals 0. B, we have 6x squared minus 6 equals -5x. And C, 2x squared minus x minus 8 is equal to 0. So let's go ahead and go on over to our notes and solve these problems. All right, so for part A, x squared minus 12x plus 20. What we want to do is we want to find the numbers that will multiply to 20 and add to -12. So we're going to write that off to the side. Two numbers that multiply, and it's important to notice that this is positive 20 and add to -12. So we want two numbers that will accomplish this. And they need to be the same two numbers. And so since it's positive 20, that means that it has to be both positive or both negative. If they were both positive numbers, they would add to a positive number. So we're pretty much stuck with this being two negative numbers since it adds to a negative number. So it may take us a while to think through all the different numbers that multiply out to 20. So this may be, 1 and 20. We also have 2 and 10, 4 and 5. So you could look at all the different combinations of that. But when you add those numbers together, they're going to equal -12. So, and they both need to be negative. So this would be like -1 and -20, -2, -10, -4, -5. And when these are added together, -1 plus -20 is -21, which is not -12. -2 plus -10 is -12. We'll just check the last one just to make sure. -4 plus -5 is -9. So that one's not right either. So we get that the two numbers that we're looking for are -2 and -10. And that may take us a little while to do, but eventually we should be able to get there. So it's -2 and -10. Those are the two numbers. So negative 2 and negative 10. So using our generic factoring technique, this means that our problem basically looks like x squared minus, and then we have our negative 2 and negative 10 in here. They would kind of result a little differently since we do have the minus. So we would get negative 2, plus negative 10 times x. And then lastly we have plus 20, which is negative 2 times negative 10. So this would check out if we simplified it. But this means that it factors into x, and typically we write plus, but these are negative numbers, so we get x plus negative 2 times x plus negative 10 equals 0. And this also equals 0. So we can simplify these a little bit. X plus a negative 2 is really just x minus 2, and x minus 10 equals 0. So from this point, we set them each equal to 0 separately. So we get x minus 2 equals 0, and x minus 10 equals 0. So we want to solve for each of those. We're going to move this just a little bit so we have some more room. So we'll move this over here. We'll draw a little line, this one over here. So for x minus 2 equals 0, we'll add 2 to both sides. We'll get x equals 2. And for x minus 10, we'll add 10 to both sides. We'll get x equals 10. And those would be our two answers. Those would be us solving for x for our quadratic equation. All right. Let's go into part B. So for part B, what we have here is 6x squared minus 6 is equal to negative 5x. Now, according to our kind of list of things that we need to do to solve quadratic equations, we need this to be equal to 0, and we need basically everything to be on the left-hand side. So we're going to get rid of this negative 5x on the right by adding 5x to both sides. So we get 6x squared plus 5x minus 6 equals 0. So now we have an equation to 0, which is what we wanted. And we see here that there is a coefficient in front of x squared. So a does not equal 1, so we can't use the factoring technique that we did for part A. Instead, we want to try to use the factoring technique for when a is not equal to 1. So remember the steps for that were to multiply the first and the last number together, expand the middle number with the two numbers that multiply to be the product of the first and last number, spread it out, group them up, get the greatest common factors, and separate them that way. So that's what we're going to do in this case. It will be factored that way. I picked it for that reason, so we will be able to do that. So let's go ahead and do it together. So we multiply the first and the last number. So we multiply 6 times negative 6. Oh, that's a 3. 6 times negative 6 equals negative 36. And now we want two numbers that add to be positive 5 from negative 36. Now negative 36 is a large number, so there's a lot of different numbers that we could try out. There's, 36 and 1, 2 and 18, 3 and 12, 4 and 9. And at that point, 4 and 9 may ring a little bit of a bell in this case. The difference between 4 and 9 is 5. And that's the number that we want to try to make them equal to, or add together to equal. So that's the one that we're going to go with. And it may take a while to find every one of those combinations and figure out which one is correct. So we have 6 times negative 6 is negative 36. We know that it has to be one is positive and one is negative in order to get a negative number. So between 4 and 9, one of them has to be negative and one has to be positive. Now the number in the middle, 5, that's a positive 5. which means that the bigger number is positive. So this is going to separate into 9 and -4. So we're going to take our quadratic equation here, 6x squared, and we're going to separate 5x. So we're going to separate 5x into plus 9x minus 4x. And then we still have minus 6 equals 0. Because 9x minus 4x is 5x. We've just expanded that middle portion now. And what we're also going to do is we're going to group them. So when we group them, we're going to put parentheses around the first and the second term, and then the last two terms. Now we notice here that there is a negative in front of 4x, so it's minus 4x and it's minus 6. Now we can put a plus in the front or we can put a minus. It's really up to you. Just go ahead and put a plus. And we've got negative 4x minus 6 equals 0. Now we're going to factor out our greatest common factor. So we're going to find the greatest common factor for the first binomial and for the second. So for the first binomial, we have 6x squared and 9x. We can definitely take out an x, but we also notice they're both divisible by 3. So we're going to take a 3x out of both. Then for our greatest common factor for negative 4x minus 6, they're both negative. Whenever that happens, it's usually a good idea to factor out a negative number. So we're going to factor out, whatever we factor out, we're going to make it negative. So we have negative 4x minus 6. Now the only thing that we can really factor out in this case is 2. They're both divisible by 2, so we're going to factor out negative 2. So when we group these, we're going to factor out our greatest common factor. So we're going to get 3x from our first group, and we'll divide each term by 3x. So that gives us 2x plus 3 in our first group times 3x. Then we're going to factor out a negative 2 from our second group. And when we do, we're left with 2x plus 3. And what we notice here is that those are the same terms, which is good. That's what we want. So we're going to factor out 2x plus 3, so it's its own term. And now we're going to put 3x plus negative 2 together as well. So we're going to get, this will be multiplied. 3x plus negative 2 is really the same as minus 2 equals 0. So 2x plus 3 times 3x minus 2 equals 0. And then we want to set both of those equal to 0 separately. So we'll go over here. 2x plus 3, 3x minus 2 equals 0. We set them each equal to 0. So we get 2x plus 3 equal to 0. Now we want to subtract the 3 from both sides. We get 2x is equal to negative 3. Then we want to divide by 2. We get x is equal to negative 3 halves. Now we'll do the other one, 3x minus 2 equals 0. So we'll add 2 to both sides. Three x equals 2. We'll divide by 3. To get x is equal to 2/3. And those are our answers. Now you could turn them into decimals and round if needed, but a lot of the time it is preferred to leave in things like square roots or fractions most of the time. All right. Now here's our last one. We have c, which is 2x squared minus x minus 8 equals 0. So for a problem like this, where, a is not equal to 1, we've got a coefficient in front of x squared, we already know that we can't use things like the generic factoring technique. So we could use the technique that we just used for part B, where we multiply the first and the last terms together. So we can multiply 2 and negative 8, which give us negative 16. And then we can try to find two numbers that multiply to negative 16 that add to negative 1. Because remember, that's the number in front of x there. If it's just by itself, it's a 1. So we can think of all the different numbers that multiply to negative 16. This would be 16 and 1, 2 and 8, and then we have 4 and 4. And that's really pretty much it. And we could go through every one of those combinations, and we would realize that none of those combinations equal negative 1 when they're added together, which means that we can't use what we did from part B either. So this is a type of problem where we can't use any of the techniques that we've talked about previously, so we'll need to use the quadratic formula. So the quadratic formula, if I can spell it right, quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a, where the a, b, and c come from our quadratic equation. So a is the number in front of x squared, b is the number in front of x, which in this case, remember, is negative 1, and c is the number at the end, which is negative 8. So we're going to use our quadratic formula and plug in all of the values. So we've got x is equal to a negative b, which is negative, and b is negative 1, so that's negative 1, double negative. Then we have plus or minus the square root of b squared, so that's negative 1 squared, minus 4 times a times c, so 4 times 2 times negative 8. And this is all divided by 2 times a, which is 2. So we've put everything in the formula, so we're going to go ahead and simplify. So a double negative is just a positive, so this is 1. Negative 1 squared is also just 1. Then we have minus 4 times 2 is 8. 8 times negative 8 is a negative 64. So we've got 1 minus negative 64. And 2 times 2 is 4. Now we have another double negative. Remember, we know that means plus, so that's really 1 plus 64. So this is 1 plus or minus the square root of 65 all over 4. So we're able to figure out and simplify this a lot now. So now we just have 1 plus or minus square root of 65 over 4. Now 65 is not going to be taken out of that square root. The only thing that 65 is factorable by is 5 and 13, and both of those are not able to be taken out of a square root. So we're just going to leave it as square root 65. Now the plus or minus means both plus and minus. Now we can't do that twice, so we separate it. So we get 1 plus square root 65 over 4, and we get 1 minus square root 65 over 4. And that creates two answers. Because when it comes to quadratic equations, you should always get two values for x, or the same number squared. So because of that, we get two answers, and so the plus and the minus accounts for both of those. So x will be 1 plus the square root 65 over 4, and x will be equal to 1 minus square root 65 over 4. Now you can certainly leave your answer in this format. Things like your homework can take it this way, but sometimes it will say that it wants you to round instead. So you can round, especially when it comes to solving a problem with the quadratic formula. Usually is actually more helpful to round your answer. So we're going to round. We put this in our calculator, and 1 plus square root of 65 over 4 should come out to about 2.27. And 1 minus square root of 65 over 4 should come out to about negative 1.77. And those would be your two answers. So all right, so we saw for each one of these, for parts A, B, and C, every time we got two values of x using three different methods. So the first one, part A, was our generic factoring technique. Step 2 was our factoring technique when A does not equal 1. And C, we had to use the quadratic formula. Now, just as a reminder, I could have used the quadratic formula with A, B, and C, and I would have gotten the same answers. But things like the generic factoring technique are definitely considered easier than using the quadratic formula. But for something like part B, it might be a little bit more of a toss-up. For part B, you would have to simplify your quadratic formula quite a bit in order to get those right answers. But with our factoring technique, we didn't have to use the quadratic formula in that way. So all right, that wraps up our example there, so let's go ahead and go back to the lecture. All right, so now we're on to our next example. There's a wide variety of plans available on the internet for DIY furniture projects. One plan for making a rectangular picnic table allows you to choose the size you want, but requires the length to be 2 feet more than the width. If you want to build a table with 20 square feet of tabletop space, what dimensions should you choose? So all right, so this one requires definitely some outside knowledge from what we just learned in our lecture today. So what this also wants us to know is basically how to get the area of a rectangle. It's a rectangular picnic table, but the size and everything is based on the area. And square feet is a big indicator of that. Whenever we have square, that means area. So 20 square feet of tabletop space is the area of the tabletop space. So we have a rectangle which tells us a width and a length, but also we're requiring that the length has to be 2 feet more than the width. So we're going to go ahead, we're going to go into our notes to figure out how to write this out and how to find our answer. All right, so for problems like these, it's best to draw a picture right off the bat. So we've got our rectangular picnic table here. And we usually say the short side, is the width. And the longer side is the length, but you can label it however you want. All right, so we have the width and the length. Now we know that the area of this picnic table, or the area of a rectangle, is length times width. But we have some requirements. Now one of our requirements here is that the length needs to be 2 feet more than the width. So length should always be width plus 2. So length is equal to width plus 2. So when we find the area of length times width, we can actually replace the length, which we know it's equal to, which is width plus 2 times the width. And this leads us into answering our problem. So having this knowledge of the area of a rectangle and then being able to replace the length with what it's equal to, which is what we said, 2 feet more than the width plus 2, we can go ahead and start kind of working this out. So if we multiply or factor in our width and simplify this equation, we get width squared plus 2 times the width. Now we're also told that area equals 20 So this leads us into our equation. 20 is equal to width squared plus 2 times the width. Now, remember, we're working on solving quadratic equations, and so we want to make sure that our trinomial is equal to 0. And we don't have a trinomial, we have a binomial, and it's not equal to 0. So we're going to go ahead and we're going to subtract 20 from both sides in order to get our trinomial equal to 0. And since it's an equation, we can switch the sides of our equation really anytime we want since they're equal. So we're going to do w squared plus 2w minus 20. It's going to be first, and we're saying that that's equal to 0. So we can use our generic factoring technique in this case because there's no coefficient in front of w squared. So we would want two numbers that multiply to negative 20 that add to 2. And so we could go through the numbers that we know multiply to negative 20. This would be things like, 1 and 20, 2 and 10, 5 and 4. We would go through all these numbers and realize that the sum of them, none of them equal positive 2. So we can't use our generic factoring technique. We have to use the quadratic formula. So since we have to use a quadratic formula, we're going to go ahead and just get that started. So there's no number in front of w squared, which means a equals 1, b is 2, and c is negative 20. So we're going to go ahead and plug these into quadratic formula. So remember, it was negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So negative b, we've got b is 2, so it's negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a, which is 1, times c, which is negative 20. And this is all divided by 2 times a, which is 2 times 1. So all right, now we're just going to try to simplify. So we've got negative 2 plus or minus, and 2 squared is 4, and 4 times 1 is 4, times negative 20 is negative 80. It's a double negative there, so we know that really just means plus. And divided by 2 times 1, which is just 2. So we get negative 2 plus or minus the square root of 84 divided by 2. So now that we're at this point, we'll just go ahead and plug this into our calculator in order to get our two answers here. You could try to simplify the square root of 84, but the reality is it's going into your calculator anyway, so you don't have to if you don't want to. When it comes to problems like these with real-world applications, you will pretty much always want to calculate to decimal. Because if you think about it, if you're talking in real-life situations and you want to know, well, how long, what should my width be if I want the area to equal 20? And if somebody says to you, oh, this is an example, but it's, going to be negative 3 plus or minus 2 times the square root of 5 all divided by 4. That doesn't really mean much to anybody in real life when you're saying that. They want to hear a number, and a decimal is okay, but they want to hear that. They don't want to hear this long expression with square roots and fractions and things like that. So whenever it comes to applicational problems, real life problems, we plug it into a calculator and find the decimal answer. So when we plug this into our calculator, remember we get that x is equal to negative 2 plus the square root of 84, all divided by 2. And we also get the minus version, to negative 2 minus square root of 84, all divided by 2. So we want to figure out what these are roughly equal to. So starting with negative 2 plus square root of 84 over 2, it should be about 3.58. And if we do negative 2 minus the square root of 84 over 2, it should be about negative 5.58. So we get two numbers. One thing we want to remember here is that we were using w before, and we did switch over to x because that does use the formula. But we want to remember this is talking about the width. So we're saying that the width should be 3.58 feet. But remember, we do get two answers. And our second answer here is telling us that the width should be negative 5.58 feet. Now, when we get answers, we also want to think about the context of these answers. Now, if we were told, hey, the width is about 3.58 feet, okay, that would make sense. But if you're told the width is negative 5.58 feet, well, you can't really have negative width. So that answer doesn't make any sense. So while you do get two numbers, one may not be useful to you. And that is most likely what will happen. One is not useful. And that's because for this type of example, we only want there to be one width. We don't want to have two different answers. We want to just have one. So negative 5.58 feet, that just doesn't make sense. So that means that 3.58 feet is what we'll use for our answer. So we get that the width is 3.58. We want to find the dimensions, so we also need the length. So if we know the width, then the length, remember from the problem, was 2 feet more than the width. So 2 plus the width. So 2 plus width. The width is 3.58. So our length is 5.58. So now we have the width and length. That's really all we needed because we just needed the dimensions, which are, the value of width and length. So we did find the dimensions. We found what we were looking for. We can always just double check our answer just to make sure that it's correct. So the area was equal to the width times the length. And so we can just plug in the values that we got, 3.58 times 5.58. And these are decimals, so they're not going to probably equal 20 exactly, but the reality is that they'll probably be very close, something like 19.98, which is what this is equal to. So this is, about 20 feet squared. So this checks off. So we can always check our answer just to double check and make sure that what we got was correct, which in this case seems correct. So, all right, there was that example. So let's go on ahead and go back to our lecture. And that wraps up our section 6.9. So in summary, in section 6.9, we learned how to identify standard form of a quadratic equation, multiply binomials using the foiling method, factor trinomials, and solve quadratic equations by factoring, and the quadratic formula. So all right, that wraps up this section, and I'll see you in the next one.